Hello everyone, Philippe here from the Metacreation Lab. I'm going to demo our new MMM4Live computer-assisted composition plugin that is AI-driven pattern generation plugin that works using MIDI as input and output. So you drag the plugin onto your master track. You have the option here to hide or show the interface. Here I have a session with a number of MIDI tracks, and I am gonna here I have a session with a number of MIDI tracks, and so here is a scene that I can play. Hello everyone, I'm Philippe from the Metacreation Lab, and today I'm going to demo the new MMM4Live plugin that is an AI-driven pattern generation plugin based on our MMM transformer deep learning model. So here you go. Here we just dragged the plugin onto the master track. You got options here to hide or show the interface of the plugin. Now this plugin takes MIDI as input and MIDI as output. So here I have a session with a number of MIDI patterns, some drum, maybe a bass line, etc. Let's listen to that session as it is. Alright, so here, one thing to note is that all the patterns are 4 bars long. 4 bar is the minimum length with which you can work with the system at the moment. There's no maximum length, but all the patterns in a given scene have to be of the same exact length. Otherwise, you're going to get an error from the system when you try to generate. So let's try by now generating a new track, maybe a track here called strings. So I'm going to select that track here, and I'm on that scene number 1. So here it appears, here this track, and I'm going to select an instrument I want to generate for. Maybe it's going to be a piano, a type of piano. So here you get all the 128 MIDI instruments, and here you have them grouped by groups of 8 instruments, so you get 16 groups. The first group is all those pianos and harpsichord, etc. So I'm going to select this, and I want to generate a full clip. It's going to be 4 bars long, and I want to let the system decide which density it finds okay. Otherwise, I can control the density between 1 and 9. And then I can choose here a medium density, for example. And I'll talk about the other parameters a little bit later. So let's generate here. So you see that the system is gonna generate a new pattern conditioned on all the existing patterns on this given scene. Here it is, this is the new pattern. Let's listen to it. Pretty rhythmic pattern. Alright, I don't mind it. Now I can also generate more than one track at a time. Here I have those 2 tracks. On this last one, I'm going to select a sort of strings, and then on the auxiliary track here, electric guitar jazz sounds like a good idea. So I want to generate full clip. I want this pretty dense, and I want this one not dense at all. There you go, I generate here. So of course, the more material I ask the system to generate, the longer it takes for the underlying algorithm to compute the patterns. So what it generates here, I can point at other parameters, generic generation parameters. The craziness here has to do with the entropy at generation time, and so the more you move it toward the right, the more the system is going to make less likely choices, maybe more experimental, less musically standard choices. And the more you're going to move toward conservative, the more it's going to make likely sort of typical choices, typical relative to the data it's been exposed to. Oh, here you go, you get a new pattern here. Let's listen to it. And a new one here too. Okay, so let's listen to this one. Oh yeah, it's been filling only the first 2 bars. And then this one. Okay. This is timpani as the instrument that the system has been choosing. Listen to the rest. All right. So now let's take this track here, and I wanna generate those 2 bars for which there was nothing generated, maybe with quite a bit of density and something not too crazy. And so here I generate only those 2 bars, so that the selected bars, as opposed to the full clip. I'll ask for a pretty high density, so it means a lot of events are being generated. Alright, so here the system picked up that I wanted to continue and apparently made choices very coherent with what the first 2 bars were about. The system is considering 8 bars at a time, so it's looking at the bars before and after what you ask it to generate, as well as of course the bars that are occurring on the other tracks, so that everything fits together. Let's listen to that result here alone, and then with the rest. Let's say that I don't really like this pattern in the end, so maybe I can choose a different group here, and then ask it to generate something that is lower density, and that is a little bit conservative maybe. So the idea like that is to interact with the system and get the system to work for you. Yeah, I like that, so I'm gonna keep that way. So this is the first example here. Now let's look at a different type of use of the system. Of course, what I can do as well is generate or change existing tracks. So here I have another set of patterns. This time they're 16 bars long, those patterns. Let's listen to this scene. So I have those 16 bar long pattern. Of course I can again ask the system to generate me some other patterns. Here I'm going to do 3 times 16 bars, and for the strings I'm going to choose the strings here. Let it choose among the string. For the auxiliary, I am going to choose maybe chromatic percussions could be nice. And then for the MK2, I'm gonna let the system choose maybe synth pad. Yeah, so with like a medium density here, the chromatic percussion with the high density, and the strings with the low density. And then let's do all that relatively neutral craziness. So of course this is a prototype, so the name the name of the sliders and all that is possibly going to change, and so don't hesitate to send us feedback so that we can work on it and eventually improve the interface. So here I'm generating 3 patterns on 3 different tracks of 16 bars each that are going to be conditioned on those 4 tracks that already exist. And when I do a generation like that, it's gonna take quite a bit of time, because it means it's a lot of work, a lot of musical events that are going to be created by the system. At a later stage, and in fact in the lab, we're working now on optimizing the model to make it run faster, and eventually to have it take a little bit less memory. For information, the model was trained on our MetaMIDI dataset. I encourage you to look at the Izmir paper that came out about this dataset and how it was compiled. It is the largest musical MIDI dataset available for research at this moment, and it's over 500,000, around 500,000 MIDI tracks, and so that's about more music than a human can listen in a lifetime, if you think about the amount of minutes of music that it represents. And so the system, in a sense, like any other musician, has been learning by listening and being exposed to musical material, and he's been exposed to quite a lot of musical material. Unfortunately, not all that musical material is of excellent quality, but somewhat the research on machine learning shows that it might not be a bad thing to have noisy data at times. It makes the system a bit more resilient, and you can ask the system things that are a little bit on the fringe, and it will still perform. Whoa, that's a lot of note here, since I asked for those 3 tracks, the string track here, and then lots happening on the auxiliary. Let's listen to these separately. Oh, yeah, this one we didn't generate. I like that. It's pad, yeah. Nice. So you get the idea. Here I just generate, but again, all the tracks have patterns of the same length. If ever a pattern is of a different length, you'll get an error message, and the system won't generate for you. So let's say that I like this, so I'm going to copy it so as not to lose it, maybe here on this scene, and then I'm going to show you another way to work with the system, which is to decide to actually take all of those patterns on all of those tracks. So I'm going to select all the tracks here and tell for that scene, I can select not all the tracks as well, but here I decided to select all of them, and I'm gonna, of course I could resample any bar that I don't like on any of those tracks here, but instead what I'm gonna do here is look at regenerating the entire piece and saying, hey, I want 50% of the bars to be regenerated. And so and then I have the choice here of, do I do that one bar at a time? That would be bar per step 1. So at each step the algorithm will generate exactly 1 bar. It means that this bar is going to be constrained on the 7 of the channel, what's happening there, as well as what's before and what's after that particular bar. So there might not be a lot of choice for the system. It might be heavily constrained. Or I can decide to generate bars 2 by 2, or 3 by 3, or 4 by 4 with this bar per step parameter. And then how many tracks do I do at a time? 1 track, 2 tracks, 3 tracks at a time? Let's say 2 tracks at a time with 2 bars per steps. And I want to regenerate 50% of the piece that way. So here I'm going to click. Here I'm going to click generate. And so this is going to take quite a little bit of time, but eventually it's going to regenerate, in a sense, half of the bar of my piece, and it's going to do so by picking randomly 2 tracks, and on those 2 tracks picking randomly 2 bars on each of those 2 tracks, and then regenerating. And it's going to do that over and over until it has regenerated 50% of the bars. So this is the type of functionality we're interested in, to maybe allow composers to make variations on existing compositions. And of course, the more the bars per step parameter and the tracks per step parameter are high, the more your variation and the more the percentage of generated steps is high, the more your percentage the more the percentage is going to be, the more the variation is going to be far from the original. So while it's calculating, I'll take the opportunity to add that for now, in this version, these are the controls that are available. We're preparing other versions where there's a lot more control over the system. And in this version as well, the system always output a fixed velocity. So it's not really, so it's quantized in terms of rhythm, and it's not really, so there's no groove. And then it's not really doing interpretation in terms of velocity either, no dynamic. And so those are functionalities that are coming in a future version, because it's very useful to have the system imitating the way humans play those various instruments that the system is capable of generating. But for now, the velocity is left to you for you to play with. Since it's still calculating, I'll also take this opportunity to say that in terms of rhythmic generation, I reckon the system is allowing you to choose here between instrument and drum. If you choose drum, then it's considering that track as a complete drum kit. And the drum generation, as you'll see, is one of the weakest part of the system in a way compared to some other capabilities of the system. I wonder if this is going to give me something. Oh yes, look at that. So we are here on scene 5, where we just resampled 50 steps of resampling. Let's listen to it. My god, it did an ending. Okay, that's fantastic. So that's it. I think this is covering pretty much all the functionalities that we have for now. Of course, there's many ways to use the system. So have fun.